Hi there, folks. Welcome to another section of non-cloud chapters. And in this chapter, I'm going to talk about SQL. And this is going to be the agenda. I'll start with SQL introduction. Then I'll talk about various database objects. You'll get to know what a database is in the discussion. In the database objects, I'll talk about database and then schema and then tables. Then I'll talk about CRUD operations. CRUD means create, read, update, and delete. And essentially in SQL, we call CRUD as insert, select, update, and delete. The term CRUD was introduced in the NoSQL world, but now it is used in a generic way. But anyway, we'll talk about insert, select, update, and delete, which refer to the CRUD operations in SQL databases. Then in the fourth topic, I'll talk about complex SQLs, wherein we'll discuss about joins, unions, excepts, etc. I'll talk about views also and a few other things. And then I'll close with analytics SQLs, wherein I'll talk about window functions, common table expressions, materialized views, etc. So the last section wherein I'm talking about analytics SQL, that is an advanced portion. And if you want, you can skip the last section also. So let me introduce SQL. So first of all, what is SQL? It is also known as SQL. So I can use the term either SQL or SQL. And SQL is used a lot actually. So the full form of SQL is structured query language. It is known as SQL or SQL. Now the first question is that why it is called structured. Why do we have the word structure itself? The reason is that it tells about the data that this particular programming language or query deals with. Whenever we are using SQL, it tells you that what kind of data you are going to deal with. You know that because we are using SQL, this is how the data would be. And that data has to have some structure associated with it. So structure is predefined in the form of tables using something called columns. Let me give you an example. So let's say this is a table, and if you have dealt with SQL, you would know that it is similar to an SQL table. And here we have multiple columns. So if I have to count, I have around 3, 3, 6, 4, 10 columns, and I have few rows. So when we are talking about structure, we are saying what these columns are. So we'll be defining that, okay, these are the names of the columns. And this is the structure of this entire table. And whatever row we put in this table should have the exact same columns everywhere. Meaning, even if you have 1 million rows, all those rows should have data corresponding to only these columns, starting from order ID and ending in discount. And then data reside in the table as rows. Now the data is basically the rows. So each row would have order ID, would have customer ID, order date, deliver date, status, price, location, quantity, sold by, discount. These columns or values for these columns should be present in all the rows. So this is what a structure is. So we define a structure of a table or an object for that matter, and data resides in this object in the form of rows. Then you have query. So what is this query? Query is basically the format or the way we deal with the data. And this is how we operate on data. We can read data, we can update it, insert data, or delete data. Now all these things are done using query. So that's what structured query means. And then you have language. Language is nothing but it is a programming language just like Python, Java, or C. So that's why it is called a structured query language or SQL. Now, after defining SQL or after telling about what SQL is, let me take you through the history of SQL at a very high level. It is a programming language to retrieve and manipulate data in databases and database objects like tables. And it was developed at IBM back in 1970. The original name of SQL was Structured English Query Language. That's why SQL is there. Then it was changed to SQL. The English word was removed from it. Now, this is the most important thing of this particular slide, that it is used as standard for RDBMS technologies. When I say RDBMS, it means Relational Database Management Systems. And just to introduce, because I told you the term RDBMS, which is Relational Database Management System, what is database? Database is a place where data or information is stored and it is persisted in disk. This is not temporary. And RDBMS is a database technology that is used to store relational data. So relational data means that in a database there can be multiple objects and those objects are related to each other. That's what RDBMS is. And some examples of relational databases are like DB2, which is basically a product from IBM itself. Then from Microsoft, we have SQL Server. Then you have Oracle, which is basically the most famous relational database till date. Now, these three are actually commercial databases, and you have to pay hefty license cost to acquire these databases. Apart from this, we have open source databases also like PostgreSQL, MySQL, MariaDB, etc. And the reason I have highlighted PostgreSQL because I'll be doing the hands-on using Postgres database. And don't worry about the other database because the SQL dialect would be more or less similar in all the databases. Now, the top row that you see DB2, SQL Server, Oracle, etc., these are actually operational databases or OLTP databases. And on the bottom part, except for Aurora, all the other technologies that I have mentioned, like Redshift, Snowflake, BigQuery, Teradata, etc., these are data warehousing systems. So this is the history of SQL, and as you can see, for the last 50 plus years, SQL has evolved a lot. The question is, who use SQL? Is it only for data engineers? Of course, data engineers use SQL a lot, but there are a lot of other personas who use SQL. For example, data scientists. And data scientists use very complex SQLs also. So if you aspire to become a data scientist, you have to know SQL. Same is the case with data analyst also. Business analysts also need SQL because business BAs or business analysts have to they do derive business functionalities, they take business decisions, etc. And business decisions are taken by data, right? So most of the business decisions are data driven and you have to analyze data, and SQL becomes imperative in this case also. Application developers, so does not matter whether you are Python developer, Java developer, or Node.js developers, sometime or the other will have to work on SQL. Of course, database administrators, machine learning engineers also have to know SQL. Then there are BI developers who use BI tools like Power BI, Tableau, Qlik, etc. They also have to know SQL to implement those BI functionalities. And finally, the marketing analysts have to use SQL also for the same reason that other personas are using. Okay, so I have talked about SQL, I have talked about the usage of SQL. I have also shown you that there are various databases which use SQL, both operational databases like Oracle, MySQL, Postgres, DB2, etc., and data warehousing systems like Redshift, Teradata, etc. Now, the question is, all these are different technologies, right? And it might be the case that they use radically different SQL. The question comes, do you have to learn those radically different SQLs? The answer is no, because SQL is completely standardized. All the database technologies that you have seen or that I have mentioned, they use some shape or form of the standardized SQL, and which is called ANSI SQL. The full form of ANSI is American National Standards Institute, and it's a organization of 270,000 organizations, maybe more than that. And that's where ANSI SQL comes. It provides certain rules, it provides certain syntaxes, maintains a certain standards and specification of how SQL should be. Which means that all the database technologies that you see, at least the relational database technologies, they have to conform to ANSI SQL because this is the standard. Now, if there comes a relational database which says no, they are not ANSI SQL, there's high chance that that relational database technology will not be adopted at all. That's why the relational database technologies have to be ANSI SQL compliant, and that is the reason that all database technologies implement subset of ANSI SQL, meaning all the database SQLs are a superset of ANSI SQL. All relational databases implement full or subset of ANSI SQL, or databases become ANSI SQL compliant. I have been talking about databases, right? So these are the various databases like Oracle, MySQL, Postgres, and you know what a database is. A database is used to store information. Now the question is, how does database store information? So that's why database server plays a very important role. So database, when I talk about database, I'm meaning relational or RDBMS databases. It is a server where data is stored, and you know what a server is. A server contains CPU, RAM, and its own storage. Storage would be associated with the server as well. So it will have a compute part and it will have a storage part. In the compute part, it would use CPU and RAM along with a lot of other things. But along with that compute, it will have a storage portion also, wherein the actual data would be persisted or stored permanently. Typically, database servers run in isolation, meaning that we do not install any other software or any other platform or any other program where database is installed, because database is one of the most critical components of an application, and it plays a very important role in the data engineering pipeline also, because this is where data is born. This is where data is captured and then sent to processing by the data engineering pipeline. So if you are using any application in your smartphone, in your laptop, in your desktop, etc., all those applications would be storing some data or the other in a database. So that's why database is one of the most critical component of any application. And also that is the reason that it runs in isolation, so that no other software can impact the database program or the database software that is running. And you might have guessed that database technologies or database server are queried using SQL. Okay, now we use SQL and send SQL statements to the database server, and the database server executes that SQL statement and sends the result back to the place where the query was sent from. Now SQL is a programming language, right? Because it is structured query language. So it also needs a server to run, because this is also a program. We need a server for SQL also, and this is called a client machine. You'll run the SQL statements in the client machine, and then you'll send it to the database server. Database server will execute it and send it back to the client machine. So this might be called as the client, and this might be called as the server. So as you can see, this is a client server architecture as well. SQL is also run from a client machine by connecting to the database server, and the connection happens over network. The client that we are going to use is called PSQL, which is basically SQL for PostgreSQL. The installation would be pretty easy, and we'll be using an EC2 instance for the client machine, and we'll be using Aurora serverless PostgreSQL for database server. So this would be the EC2 instance, and this would be the Aurora PostgreSQL database server.